Hey, ANPers, this is Dr. Jones checking in. This is ANP1, Lecture Test 1, Video 14. So we talked about non-membranous organelles in the previous video, and we're talking about membranous organelles today. And this is top of page 22 in my note set. So at the top of the page, please draw a line, and under the line, please write the word membranous. And then please list the membranous organelles. We're going to cover them all one by one. So let's start with the endoplasmic reticulum. The endoplasmic reticulum, is it membranous or non-membranous? Well, we're in the membranous organelle section, so I'm going to go with membranous. Plus, I mean, look at it. It's got a membrane. So endo means within, plasm refers to the cytoplasm, and a reticulum is a network. So this is a network of chambers inside the cytoplasm. And the chambers are called cisternae. Let's see what I've got written down for technical definition here. Hollow chambers in ER, ER for endoplasmic reticulum. And if you're caught up on the lab videos, which you need to go get caught up if you aren't, you'll know that there are two kinds of ER, SER and RER. SER and RER are for no credit on the lab test. You need to write out smooth endoplasmic reticulum and rough endoplasmic reticulum correctly spelled if you want any credit. So like literally you get a letter wrong and you won't get credit. When I have time, I do go through and give partial credit if the spelling is within one letter. So, spelling counts. 4 major functions of the endoplasmic reticulum. Number 1, synthesis. So, making stuff. The ER makes proteins, carbs, and lipids. Proteins, carbs, and lipids. 2 is storage. Nice place to store stuff. 3 is transport, because stuff that's made here gets moved through the cisternae to other places. And 4 is detox, and this is mainly in the liver, and we actually aren't going to talk about this very much. And the cisternae, we said, are hollow chambers in the ER, and here's what the ER looks like. The rough endoplasmic reticulum, of course, is rough because of the fixed ribosomes. The smooth endoplasmic reticulum has no ribosomes. And so you need to be able to identify these RER versus SER on this picture, which is on the test. All right, and my face is in the way. Move face. Okay. Yeah, that works. All right. So the SER, does it have ribosomes? No. Does the RER have ribosomes? Yes. So what do ribosomes make? Protein. So we said that the fixed ribosomes make proteins for use outside the cell because they get transported by the rough endoplasmic reticulum. The smooth endoplasmic reticulum has no ribosomes, so it can't make proteins. What does it make if it can't make proteins? It makes carbs and lipids. And to be clear, these are the proteins that are for use outside the cell. Okay. There's the rest of that picture. All right. So when these products are made, they are packaged up into transport vesicles. And, okay, I need that corner. Oh, ooh, we have questions. All right. Why would a cell that makes digestive enzymes have a lot of RER? Well, what did we say about enzymes twice this semester already? That all enzymes are proteins. And what makes proteins for use outside the cell? The ribosomes of the RER. So you would expect any cell that makes digestive enzymes to have a lot of RER. And also, y'all are college educated now. I want you to notice that a lot is 2 words. A lot. There's a space there. So that caret means add, And the hashtag means space. That's what that means, really. So a lot is actually 2 words, and y'all are college educated now, so now you know that a lot is 2 words with a space. Why would a cell that makes earwax, which is called cerumen, have lots of SER? What's SER make? Carbs and lipids. What does earwax have to do with carbs and lipids? Oh, the lipids are fats, oils, and waxes. That's right. Got it. Got it. All right, so transport vesicles carry proteins, and I am still in the way. There we go. I didn't make these slides for the contingency that I would need my face in a box in them. Global pandemic was not on my list of concerns when I made these. The education must go on. So transport vesicles carry proteins from the ER to the Golgi bodies. You can call them Golgi bodies or the Golgi apparatus. Either way works. Describe the Golgi apparatus. It is a, they said a stack of dinner plates. Okay. And it acts as the Amazon warehouse. If the endoplasmic reticulum is the manufacturing space, I think someone's hammering right outside my window. I don't know if you can hear that or not. I see my son out the window. Usually it's my father-in-law that's hammering things. I don't know. Makes me happy. Going with it. So if the ER is the manufacturing space, then the Golgi is the shipping warehouse, the Amazon warehouse, if you will, where it puts stuff all in the box together and gets it ready to secrete. So it makes, the Golgi makes 3 types of vesicle. A vesicle is a membrane-bound bubble. And when I say membrane-bound, I'm talking about a phospholipid bilayer, just like the cell membrane. It's all the same membrane. Membrane-bound, membranous organelle, cell membrane, it's a phospholipid bilayer. That's what it is. Okay, so it makes these secretory vesicles, which is different than a secretary, which is administrative assistant now. But it secretes stuff. So secrete, secretory. Not that it tells secrets, but that it secretes. Slightly different. And it also changes the membrane, which we will talk about in membrane renewal vesicles. And then my favorite are the lysozymes. It makes lysozymes, and they're called lysozymes. We'll talk about those next. And here's what a Golgi actually looks like IRL. And my head is in the way. Okay, gotcha. Lysosomes. So lyso is for lysis, it's a loosening of, and some is from soma, and that means body, so it's a digesting body. And what membranous organelle produces lysosomes? The Golgi body or Golgi apparatus. What do lysosomes contain? Powerful digestive enzymes. So enzymes are proteins, and it contains powerful digestive enzymes. Explain lysozyme function. We've got 3 functions. It digests damaged organelles. It digests materials from outside the cell, and it digests the cell it's in if it dies, when it dies. So here you have picture form. The Golgi makes the primary lysosome. So say that the cell eats endocytosis, a bit, maybe a bacterium, and then the lysosome membrane, which is a phospholipid bilayer, combines with the endosome membrane, which is cell membrane that's budded off, so still a phospholipid bilayer, and then those bind together, releasing the enzymes on the crud that your cell membrane ingested, that surrounded. And then it digests it, and the nutrients are reabsorbed back into the cytosol so that your cell can use them again. And then the wastes are pooped out, and exocytosis is cell pooping, which we'll cover later in the chapter. Okay. So also what can happen, here's a damaged organelle, combines or is surrounded by the secondary lysosome. Good stuff is reabsorbed, bad stuff is pooped out, which is exocytosis. And also if this cell dies, then the lysosome cell membrane dissolves and releases its powerful digestive enzyme, and it eats the cell it's in from the inside. And like, we don't know yet. How does the lysosome know? How does the lysosome know that your cell is alive and it's not time to eat the cell? How does the lysosome know that your cell is dead and it's time to break down and release the dogs, the kraken, the lysosomes, the powerful digestive enzymes? And we don't know. And some people are born with lysosomes that don't work right, and they eat the live cells, and that is not good, not good. So it's really interesting, and I'm anxiously waiting. Hopefully we find out how to fix these lysosome problems so that babies born with lysosome membrane issues can live. So, science, ever moving on. Oh, so autolysis is self-digestion. Auto means self, and lysis, of course, is a loosening of. So auto means self, like an automobile moves itself. Automatic. Okay, next are peroxisomes. Peroxisomes are these little buddy things, and they are produced by the budding off of existing peroxisomes. So you have a peroxisome, and it just like, you have a peroxisome, and it's just like, boom, now you got two peroxisomes. And it absorbs and digests fats and other organic compounds. So we've had lysosomes we had proteasomes to digest proteins, and lysosomes with just powerful digestive enzymes to digest a bunch of stuff. And these peroxisomes digest fats and other stuff, neutralize toxic compounds, yada yada. Okay. All right, mitochondria. Mitochondria are the powerhouse of the cell because they make ATP. We talked about ATP, adenosine triphosphate, in the chemistry chapter. When you phosphorylate the third phosphate on, it makes the highest energy bond. And when you snap that third phosphate off, then it releases a type of energy that your cells can use. So it is a high energy compound. Okay, so the mitochondria, they have an outer membrane, which is the outside bit, and then an inner membrane, which is inside the outer membrane. And the outer membrane surrounds the organelle. The inner membrane will actually be the location of ATP synthesis. And we will come back to this at the test 5 of 2402, and we will cover the basics of biochem very quickly, because as you know, I'm not a huge biochem fan. In fact, there was an adjunct teaching A&P at Del Mar for a while, 10 years ago, who was a dual like PhD in biochem and like had been an MD student. Anyway, and I told him once, like, you know, all due respect, but biochem's not my thing. And he said, well, sometimes it's the master that leads you through the garden. I'm like, nope. It's like, I don't care how your mom cooks salmon, it's still salmon. Okay. So, although I'm sure it's perfectly lovely salmon for salmon. So the inner membrane is the location of ATP synthesis, which we will discover more about next semester. The inner membrane has these little folds. See the folds? The folds are called cristae. And then the stuff inside, in between the folds, is matrix. So these are all terms you need to know. The mitochondria make the high energy compound ATP, adenosine triphosphate, and you would expect a skeletal muscle cell to have a lot, which is 2 words, of mitochondria, because skeletal muscles need energy to move. Lots of energy. Lots of energy. Okay, so now let's talk about membrane flow, and then we will cover the nucleus by itself in the next video. So we'll go part way through this page. Membrane flow. The organelles that contribute to the membrane flow include the RER, SER, Golgi, peroxisomes, and lysosomes, which is basically all of the membranous organelles. Okay, all of the membranous organelles with a single membrane. So the mitochondria don't contribute, but they have a double membrane, and the nucleus does not contribute, but it also has a double membrane. So double membrane organelles need not apply. So this is the RER, SER, Golgi, peroxisomes, and lysosomes, which does not answer the question, what is membrane flow? Membrane flow, explain how membrane flow contributes to homeostasis. So it allows the cell to rapidly respond to changes in the environment. And what happens is these membrane renewal vesicles can be formed with different receptors. Like, say you need more insulin receptors on the surface of the cell. So you build more cell membrane and you just completely stud it with insulin receptors. And then you add that to the cell membrane. So now you have cell membrane with more insulin receptors. And in fact, the book says that in an active cell, you can actually completely change the cell membrane, all new cell membrane, in an hour. The third blink was just because I still think it's fascinating. So that's part of how we said that cells respond to the external environment. Well, depending on the external environment, they can put out in an hour in an active cell an entirely new membrane with more receptors for what it needs or fewer receptors for what it doesn't need. In fact, we'll name those concepts next semester when we do endocrine for test 2. But it's really cool that all of these organelles can work together to build you a whole new membrane to respond to the changes in reality. So I still think that's cool. Lysosomes are still my favorite though. So anyway, this has been AMP1 lecture. I get so off topic. AMP1 lecture test 1 video 14, and we covered NoteSet page 22 and about 2/3 of page 23. So we will come back for video 15. We will start on page 23, and it will be the nucleus. So we covered membranous in this video. M-E-R-A-N-O-U-S, membranous. And then the next video will be the nucleus video. Thank you as always for tuning in. It's so nice to virtually see you here. And the education must go on. Dr. J out.